Okay, we're in the second part of section 5.3. We're getting to a theorem that I think is a tad bit confusing, so go through it slowly. It's Theorem 5.7, concurrency of angled bisectors of a triangle. We learned about concurrency in section 5.2. Let me read the definition real quick for you. Concurrency. When three or more lines, rays, or segments intersect in the same point, they are called concurrent lines, rays, or segments. The point of intersection of the lines, rays, or segments is called the point of concurrency. Okay, that was from section 5.2. So let's look at this one, concurrency of angled bisectors of a triangle. Key here for me to remember is concurrency of angled bisectors. Last time we did concurrency of triangle bisectors. So the angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. Okay, so I'm going to draw the angle bisectors here in red. It should go, it should bisect the angle. I'm trying to get right in the middle. I just drew, I don't like that one. 3 angle bisectors. No, not much better. Okay, they intersect in the middle, which we're going to say is point P. So, if AP, BP, and CP are angle bisectors of triangle ABC, then PD is equal to PE. Oops. Get that red, is equal to PF. Okay, let's look at that again. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. If segment AP, segment BP, and segment CP are angle bisectors of a triangle ABC, then PD equals PE equals PF. Okay, a reminder here, these are segments or pictures, these are measurements. Okay, when I have a line over it, it's a segment or a picture. When it's no line with an equal sign, it's a measurement. So remember, an angle bisector of a triangle is the bisector of the interior angle of the triangle. Okay, so all of these angles, those are congruent, those are congruent, those are congruent. All right, to take that one step further, the point of concurrency, which is P, of the 3 angle bisectors of a triangle is called the incenter of the triangle. It's a new word. Okay, the incenter always lies inside the triangle. Because the incenter P is equidistant from the 3 sides of the triangle, a circle drawn using P as the center and the distance to one side as the radius will just touch the other 2 sides. The circle is said to be inscribed within the triangle. The circle is perfectly inside the triangle, touching each side. So here we have P is the center, the incenter, and I drew a circle inscribed inside the triangle. So the measure of the triangle bisectors are the radius. These are all equal. Okay, it's pretty cool. In the diagram, N is the incenter of triangle ABC. Find ND. Okay, we're going to have to use Pythagorean theorem again. Okay, we're going to find ND. So that is right here. Okay, we know that triangle NAF, let me draw that out. Okay, these are all given to us. The sides, I look at triangle NAF. We know 2 of the sides, and this angle is right. So I can find this blue segment right here, NF. I want to know what NF is. Because NF is equal to ND. Okay, I don't have enough information to find ND, but I do have enough information to find NF. So let's use the Pythagorean theorem. A squared plus B squared equals C squared, where A, B, and C, if I have a right triangle, A and B are the legs of the right triangle, and C is the hypotenuse. Okay, the hypotenuse is across from the right angle. So C is 20. A is 16, and we don't know what B is. Okay, 16 squared is 256. 20 squared is 400. 400. Okay, square root of both sides. B equals 12. So B is the measure of NF. So NF equals 12, and NF and ND are equal, so ND equals 12. Okay, you try this one. Same sort of problem. Suppose you're not given AF, let me scribble that out because I just copied this diagram over, or AN, but you are given that BF equals 12, and BN equals 13. Find ND. Okay, same type of problem. This is the triangle that I know the most about. I've got two sides of it, and it's a right triangle, so I can use the Pythagorean theorem to find NF. And once we find NF, we know that NF is equal to ND. And we're done. Okay, so go ahead and try that one on your own. Okay, I did the problem almost exactly the same as I did the last problem. So I got B equals 5, which is equal to NF, and since NF and ND are congruent, are equal, then ND equals 5. Daily homework quiz, page 1. 2 points extra credit, remember? Just put it on a separate sheet of paper and put it in the inbox. Page 2. Page 3. That's all we have for today.